Hi, and welcome to How to Improve Science Performance Through Strategic Note-Taking.
Today's topic is speed, distance, and time. Speed. What is speed? You've probably heard of speed before. Some people talk about how fast their car is, or maybe how fast they run, or even that snails are really, really, really slow. You know, the fastest human runs almost 30 miles an hour, and the cheetah over doubles that at 70 miles an hour. And there's even a jet called the Blackbird that can travel 2,200 miles per hour. That means it can travel the entire Earth in around 11 hours. So, how fast are you? To understand speed, we also have to understand distance and time. Take note that distance is the amount of change in position. Distance is the amount of change in position. We think of distance as how far something is moved from one place to another. One important thing you must remember that distance is always positive. It's not possible to travel a negative distance. That doesn't make any sense. It doesn't matter what direction the object goes, to the right, to the left, up or down, inside or outside. The distance is the cumulative travel from the start to the finish. It's kind of like an odometer on a car. It keeps adding up the distance, and it doesn't matter which direction you are going. Units for distance include meters, feet, miles, kilometers. But you do need to write this down. We show distance with the letter D. We show distance with the letter D. You must also understand that time is the difference between then and now. Time is the difference between then and now. We measure time with clocks, calendars, stopwatches, etc. Time is measured from a starting time to an ending time. Time can be measured in hours, seconds, minutes, years, etc. You also need to write this down. We represent time with the letter T. We represent time with the letter T. We must use time and distance when we try to find speed. We must use time and distance when we try to find speed. Now, that we understand distance and time a little bit, we can work to find speed. You need to know that speed is the rate at which something changes location. Speed is the rate at which something changes location. If an object moves a given distance in a short time interval, we say that that speed is rapid or fast. If the object moves the same distance in a longer time interval, we say that its speed is slow. Speed is the distance per unit time. Think of 100 kilometers per hour, distance and time. Just for reference, from now on, we'll almost always use metric units because we use the metric system in science. And just so you know, for reference, 1 kilometer per hour equals about 0.62 miles per hour. So when I say a car is going 100 kilometers per hour, that means it's going about 62 miles an hour, so you have a clue about how fast that is. Next, you need to write this down. We represent speed with the letter V. We actually use V to represent speed. V stands for velocity, which we're going to cover later on more depth. So speed is the distance something goes in a unit of time. The basic speed question is, how fast did it go? Well, to answer this question, we find out how far it went in a certain amount of time. An equation that's useful for calculating speed or velocity is v equals d divided by delta t. So please know that v equals d over delta t. And remember, we're going to say speed for velocity. So also write this down. Delta, the triangle that you see, represents the word delta, which means change. So triangle means delta, which means change. We use this to represent change in time, the difference between then and now. This way, we don't have to mention that it's the difference between the starting time and ending time every time we solve a speed problem. V equals d over delta t shows that speed is directly proportional to distance and inversely proportional to time. What does that mean? Well, here's what it means. That means that as distance increases, as distance gets bigger, the speed also increases or gets bigger. It also means that as time increases or gets bigger, that our speed decreases or gets smaller. We can use the speed equation to solve for speed, but we can also solve for distance and time using the same equation. You might do this in an algebra class. In this equation, we have three variables: distance, speed, and time. As long as you know two of the three variables, you can solve for the third. So if we know distance and time, we can solve for speed. So draw this triangle. You'll see V, D, and T. So if I know speed and if I know time, I can solve for distance. So my distance would equal my velocity multiplied by my time. If I know speed and distance, then I can solve for time. My time equals my distance divided by my speed. There are other ways to solve for this as well that you may learn at another time. So let's review. Speed is the rate at which something changes its location. We need to know distance is the change in position of an object, and we need to know that time is from then until now. We also use the distance and time in our speed equation. Speed equals distance divided by the change of time. Knowing this, we can learn about average speed and also velocity in another lecture.